Science is often seen as a realm of pure logic, rigorous testing, and undeniable proof. We imagine breakthroughs emerging from meticulous experiments and carefully constructed theories. But sometimes, the path to discovery takes a turn so unexpected, so uncanny, it feels less like a formula and more like fate. From accidental observations that reshaped our understanding of life to simultaneous insights that defied explanation, these moments remind us that the universe holds a peculiar sense of humor. Join us as we explore the most astonishing twists of scientific destiny. Here are the top 10 strangest coincidences in science. Our journey begins in 1928 with Alexander Fleming, a bacteriologist at St. Mary's Hospital in London. He was known for being a bit untidy in his lab, a trait that would inadvertently change the course of human history. One day, before leaving for a vacation, he stacked some Petri dishes containing Staphylococcus bacteria. Upon his return, Fleming noticed something peculiar in one of the dishes he had left uncovered. A patch of mold had grown and, even more remarkably, the bacteria around it had been completely destroyed. This wasn't just a contaminated sample, it was a profound observation. That seemingly insignificant mistake, that single oversight, led to the identification of penicillin. This mold, Penicillium notatum, produced a substance capable of killing harmful bacteria. Fleming's accidental discovery ushered in the age of antibiotics, saving countless lives and revolutionizing medicine forever. The image of Isaac Newton sitting under an apple tree, only for a falling apple to spark his theory of gravity, is one of science's most enduring legends. While the story has certainly been embellished over time, its core idea points to a profound moment of insight. It suggests that a common, everyday occurrence can unlock universal truths. Newton himself recounted variations of this tale, emphasizing how the simple act of an apple falling prompted him to ponder why it fell straight down, rather than sideways or upwards. This seemingly trivial event led him to question the forces governing motion on Earth and in the heavens. The coincidence wasn't just the apple's fall, but its timing with Newton's already deep contemplation of celestial mechanics. It served as a catalyst, connecting the terrestrial pull of gravity to the unseen forces holding planets in orbit. This moment, whether literal or metaphorical, inspired one of science's biggest breakthroughs, the law of universal gravitation. Imagine a world without instant popcorn or quickly reheated leftovers. We owe this modern convenience to another remarkable accident involving an engineer named Percy Spencer. In 1945, Spencer was working for Raytheon, developing magnetrons for radar equipment. These devices generated high-frequency radio waves. During one experiment, Spencer was standing near an active magnetron when he noticed a strange sensation. A chocolate bar in his pocket began to melt. Intrigued, he immediately recognized that the microwaves emitted by the magnetron were responsible for the rapid heating. He then experimented with other foods, including popcorn kernels and an egg, which famously exploded in a colleague's face. Spencer quickly realized the potential for cooking with these waves. This happy accident led directly to the invention of the microwave oven, transforming kitchens worldwide and demonstrating the unexpected applications of military technology. Few scientific coincidences are as striking as the near-simultaneous development of the theory of evolution by natural selection. Charles Darwin had spent decades meticulously gathering evidence and refining his ideas after his voyage on the HMS Beagle. He was on the verge of publishing his monumental work. Meanwhile, thousands of miles away in the Malay archipelago, a young naturalist named Alfred Russel Wallace was independently arriving at the same groundbreaking conclusion. Wallace, suffering from a fever, had a sudden epiphany about how species adapt and change over generations. He quickly penned an essay outlining his theory. In 1858, Wallace sent his manuscript to Darwin for review, completely unaware of Darwin's own extensive work. The striking similarity of their ideas was undeniable. This extraordinary coincidence led to their joint presentation of the theory to the Linnean Society, forever reshaping biology and our understanding of life on Earth. In the 19th century, astronomers faced a perplexing problem. The orbit of Mercury didn't quite match Newton's laws of gravity. It precessed or shifted slightly more than predicted. To explain this anomaly, many scientists hypothesized the existence of an unseen planet orbiting even closer to the Sun than Mercury. They named this hypothetical world Vulcan. For decades, the search for Vulcan consumed astronomers. There were even several reported sightings, though none could be definitively confirmed. The belief in Vulcan was so strong that it became a widely accepted, albeit unobserved, part of the solar system. It was a testament to the prevailing Newtonian framework. The coincidence here is not just the belief in a phantom planet, but how perfectly it fit the scientific understanding of the time. It wasn't until Albert Einstein published his theory of general relativity in 1915 that the mystery was solved. Einstein's theory accurately explained Mercury's orbital precession without needing any additional planets, rendering Vulcan a fascinating historical footnote. The invention of the telephone is often solely attributed to Alexander Graham Bell, but the story is far more complex and involves an incredible coincidence. On February 14, 1876, both Bell and another inventor, Elisha Gray, filed patent applications for devices that could transmit vocal sounds electrically. They did so on the very same day. Gray, an electrical engineer, had developed a liquid transmitter design that was remarkably similar to Bell's. He filed a caveat, which was a preliminary notice of an invention, just hours before Bell's lawyer filed his full patent application. The race was incredibly close, a true photo finish in the history of innovation. Bell's application was processed first, granting him the official credit and the patent. This astonishing coincidence sparked years of legal battles and intense rivalry, with Gray and others challenging Bell's claim. Ultimately, Bell's patent stood, but the near-simultaneous invention highlights how scientific and technological progress often emerges from multiple minds working on similar problems. The Danish astronomer Tycho Brahe was a larger-than-life figure, known for his eccentricities as much as his scientific prowess. In 1566, as a young man, he engaged in a duel with a fellow student over a mathematical formula. The duel resulted in Brahe losing a significant portion of his nose. From then on, Brahe wore a prosthetic nose, reportedly made of brass, which he would attach with a paste. This personal tragedy, however, had an unexpected scientific consequence. The injury seemed to fuel an almost obsessive dedication to precision and measurement in his astronomical work. Brahe became renowned for his incredibly accurate and comprehensive astronomical observations, made without the aid of a telescope. His meticulous data, gathered over decades, became invaluable. Years later, this very data was inherited by his assistant, Johannes Kepler, who used it to formulate his groundbreaking laws of planetary motion. A personal misfortune inadvertently provided the foundation for a revolution in astronomy. The discovery of Neptune is a testament to the power of mathematical prediction and an astonishing coincidence of timing. In the early 19th century, astronomers noticed that the planet Uranus wasn't following its predicted orbital path. Its movement suggested that an unseen gravitational force was tugging at it. Two brilliant mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently set out to calculate the position of this hypothetical perturbing planet. Working separately and without knowledge of each other's efforts, they both arrived at remarkably similar predictions for the new planet's location. Le Verrier sent his calculations to astronomer Johann Galle at the Berlin Observatory. On September 23, 1846, Galle pointed his telescope to the exact spot Le Verrier indicated. Within an hour, he found a new planet, almost precisely where the calculations suggested. This incredible coincidence of independent prediction and immediate confirmation solidified the power of Newtonian mechanics and expanded our solar system. The structure of benzene, a fundamental organic compound, puzzled chemists for decades in the mid-19th century. Its formula, C6H6, suggested a highly unsaturated molecule, yet it behaved like a saturated one. Chemist August Kekule struggled intensely with this problem, often falling into daydreams while working. One evening in 1865, while dozing by the fire, Kekule had a vivid dream. He saw atoms dancing, forming chains, and then, in a flash, he saw a snake biting its own tail. This ancient symbol of infinity, the Ouroboros, provided the crucial insight he needed. Kekule awoke with the realization that benzene was not an open chain, but a closed ring structure. This dream, a seemingly random subconscious event, provided the key to understanding aromatic chemistry. His snake dream led to the correct ring structure of benzene, a cornerstone of organic chemistry that underpins countless modern materials and medicines. Albert Einstein's theory of general relativity, published in 1915, proposed a radical new understanding of gravity, suggesting that massive objects warp space-time itself. One of its most audacious predictions was that light from distant stars would bend as it passed near a massive object like the Sun. However, proving this required a very specific celestial event. The perfect opportunity arose with a total solar eclipse predicted for May 29, 1919. During an eclipse, the Moon blocks the Sun's blinding light, allowing stars near the Sun's edge to become visible. This rare event provided the ideal conditions to test Einstein's theory. Astronomer Arthur Eddington led expeditions to observe the eclipse from two different locations. When the photographic plates were developed, they showed that the starlight had indeed bent by the exact amount predicted by Einstein's equations. This cosmic coincidence, a perfectly timed eclipse aligning with a revolutionary prediction, catapulted Einstein to global fame and fundamentally changed our understanding of the universe. From melted candy bars to dreams of snakes, these coincidences shaped science as we know it. They remind us that discovery isn't always a straight line, but often a winding path filled with unexpected turns, lucky breaks, and moments of pure, unadulterated wonder. Which one of these astonishing scientific coincidences amazed you the most? Was it the accidental mold that saved millions, or the dream that unlocked a chemical secret? Tell us in the comments below. And don't forget to like and subscribe for more strange history and mysteries every week.